Alright everybody, here's another friction problem. They have given us the kinetic friction between the 100 kilogram box and the inclined surface, and that is 0.35, and they are asking us to determine the tension T necessary to pull the box up the surface at a constant rate. So what I'm going to do here is I'm going to actually kind of draw this kind of big to help us look at what we're doing here. So here's our box. And let's go ahead and draw our forces on here. So we're going to have our weight, which is going to be 981 newtons. Well, why? Because it's 100 kilograms times 9.81 is going to give us 981. Now it's going to be pulling up, right? So we're going to be pulling up with this tension. So we're going to have this tension that's pulling up on here. And we have this angle here at 60 degrees. We have our normal force, and again our friction is going to be acting down in this case because the box is moving up. Alright, so I'm going to erase this just to kind of see if we can get this a little bit more, because this is what really confused me when I was going to school, is how to find these different angles. So alright, so when I'm looking at this angle 60 degrees, if I draw this here, and then I can draw this here, well, what is this angle and what is this angle? Well, this angle here is 60 degrees. And really the only way I can try and explain this is if I rotated this box this way, to where this would be my x-axis. So it would look something like this. I'll draw it in the same color. So if I did this and I rotated it 60, this line here is this line here, and this line is this line. So this 981 newtons would be acting here. But since I rotated it 60 degrees, this here is our 60 degrees. So that's why I know this is 60 degrees here. That's how I see it in my head. Now I'm going to erase this real quick and kind of draw it in here. So we know this is 60 degrees. Now when I start looking at this 981 Newton force, I'm going to have to break it up into its components. So I'm going to have this component, and I'm going to have this component as well. So how I would start this problem is I would sum my forces. Write this in black. Let's sum my forces, and I'm going to say that this way, the way that the tension is going up, I should have my tension here, the tension is going up is going to be positive. So I'm going to have my tension minus, now I'm going to look at this right here, this is the force that I'm looking at, minus 981 newtons times the sine of 60. And then I'm going to have the friction, which is also going to be going down. So I'm going to be subtracting my friction, is all equal to 0. Then if I sum my forces, where this is positive, this direction is positive. I guess I should have put that there as well. It's equal to 0. Well, what do I have there? Well, I have my normal force, which I'm going to say is positive. And then I'm going to have this 981 newtons going to the left, but that's going to be times the cosine of 60. So that's going to be negative 981 newtons times the cosine of 60 degrees. And that's all equal to 0. So let's go ahead and solve for n, since there's only one unknown here. Here we have two, so just one unknown. So our normal comes out to be 490.5 newtons. 490.5 newtons. So now let's use our equation for friction. And I like what the guy in the video from Texas Tech says. You know, this is fun, right? All these problems are fun. This is kinetic friction. So friction then was given at 0.35, remember that's 0.35 right there, times our normal force that we just calculated. So our friction is going to be 171.67 pounds. Now I can take this value and put it in here. So I know that tension minus 981 times the sine of 60 minus the friction, or let's go ahead and plug what we have in for friction there. 171.67 newtons is all equal to 0. So plugging that in, we get that tension is 1021.24 newtons. But let's take a look at this. If I draw the free body diagram of this box, I keep doing that. Draw a little bit bigger. Let's try all this again. I draw this box. I'm going to have this pulley. It's connected. And then I have this cord rope that's hanging on to the box here. And I have, so all these are pulling up. So if we look at this, the mechanical advantage is actually 3 to 1. So it's 3 times easier when we pull here than it would be if we were just yanking it down as so. So the mechanical advantage is 3 to 1. We would divide by 3, and we would say that this is going to be 340 newtons to pull up at a constant rate. The other thing that you could have done is, if you knew this was 3 to 1, you could have just put a 3 here, because you know it's a mechanical advantage of 3, and you would come up with 340 newtons, because 3t divided by 3. So I hope this helps a little bit. I know that this angle thing really got me back in the day, so try and take a look at it, try and figure out what makes sense to you in order to solve that angle. Alright, thanks.